So when we think about these characteristics of water, there's a couple important ones that aren't just cool to know, but they're super helpful as we kind of think forward on how water is so beneficial and impactful to different things here on Earth. So our first one here is this idea of transmission. Transmission is simply the property of water being clear. Because the water is clear, it's really allowing light to pass through. So in the little example that we did in class, we saw the coin down at the bottom of the cup of water simply because the water is clear. That allows the light to pass through. The clear particles of water reflect off the coin and to our eyes, so we can essentially see that reflected light and whatever object is doing the reflecting. Now, we talked through in class how this is not really possible if we're trying to do this with coffee. The light will not flow through the coffee like it does with the water. It is mostly absorbed, not allowing the light to get to the substances at the bottom, allowing us to see them. So transmission is simply the idea that water is clear and allows that light to pass through. And most importantly, well, how does that apply to aquatic plants? So these plants are here underneath some sort of level of water, but yet they are thriving, right? They have enough life and energy to live underneath all this water in a very different environment than something on the surface. So this idea of transmission makes it possible for those plants to thrive underwater because the simple fact that the water's clear. Just like here, the light is able to pass through to reach the objects at the bottom. Same thing is happening here. These plants need to go through photosynthesis, the process of taking in both CO2 and sunlight to get the food and sugars they need to thrive and live and survive. So if our water was looking more like our coffee, these plants could not exist. And some of you realize, if you're going deep down into the ocean, the depths are too far for the light to get all the way through. We don't have plants there. So there's kind of a sweet spot or a zone where plants can live under a certain depth of water with certain levels of clarity because of this property of transmission, allowing light to pass through, and in the case of our plants, get that sunlight to them so they're able to do their photosynthesis and live. Our second thing we're thinking about here is this idea of expansion. So as water is frozen and converts to ice, we see two very different property changes, one having to do with volume and one having to do with density. So water in its natural state is, like most liquids, kind of a medium density, right? These particles are just hanging out in their liquid state, but something happens with water specifically. When it freezes into ice, we notice here that the particles expand and they rearrange into this open structure pattern. And so that expansion of the particles from their liquid to their solid state make two very different changes. We see an increase in volume. So remember, volume is thinking about the space that an object takes up. So because the particles are expanding out, the space that they take up also gets larger. So we saw that in both pictures and with our graduated cylinder, how the actual amount of material appeared larger, even though we didn't add or take out any mass or atoms. No more particles went in. Just the fact that this open structure expands the space in between creates an increase in volume. And same thing with density. Density is how compact particles are. A more dense substance has more compact particles and will therefore sink. A less dense subject or substance has particles spread out and it will therefore float. So when we think about the liquid water compared to the solid ice, we notice they're more spread out in the ice, which is very unusual for a solid. But because, again, those particles expand and they go into this open structure form when it freezes, the solid becomes less dense, and that's why we see ice floating on the surfaces. Our last two properties we're thinking about are cohesion and adhesion. Cohesion, just the simple idea that water molecules like to stick to themselves or are attracted to themselves. And so we see that in the picture here. They like to stay together. You saw a little video in our activity with those water drops on the coin, right? They stayed kind of in that little bubble sort of shape or structure. They didn't just roll off to the floor, but the molecules themselves are hanging out together, and once enough accumulated, it really looked like a big bubble happening on top of that coin. They'd rather be cohesive and stick together. On the flip side, different things can cause the adhesion of water to increase. Adhesion, you saw this example in the video where the water was sticking to another surface like that paper towel. So there is a property of water. Not only is it wanting to stay together with itself, but it's also very adhesive to other substances. So rather than just touching the water and moving off, it adheres to it, right? And it was absorbed all the way up that paper towel. So both of those properties are specific to many particles, but that's what we see for both of them with water.